is your part 1 video for 5-4 solving radical equations. So our essential question for this section, how can you solve equations that include radicals or rational exponents? So we will be looking at both types of equations as we move through this section. So our first example, we have two parts. Part A just says solve the radical equation. We have the square root of x plus 5 minus 1 is equal to 3. Anytime you are solving a radical that has a radical equation that has one radical, you want to isolate that radical. So my first step here is going to be to add the 1. And I get the square root of x plus 5 is equal to 4. At this point, we need to undo the radical. So to do that, we're going to square both sides of the equation. The square and the square root are going to undo each other, so we're just left with x plus 5. 4 squared then is 16. To finish it up, I'm going to subtract the 5, and I get x equals 11. Now before I box that in, I do want to check and make sure that that actually does work in the original equation. So to do my check, I'm going to plug the 11 back in. I want to see if 11 plus 5, when I take the square root and subtract 1, I get 3. Well, 11 plus 5 is 16, and the square root of 16 is 4. So that does, in fact, work out to be 3 whenever you subtract the 1. So 11 is our solution for part A. For part B, we have the radical equation. The cube root of x plus 2 is 4. Again, I have a solitary radical, so I want to get that radical by itself. So I'm going to subtract the 2. I get the cube root of x is equal to 2. Now I have to undo the cube root, and I'm going to do that by raising each side to the third power. The cube root and the cube are going to undo each other, so I'm just left with x. And then 2 cubed is 8. Now again, before I can box that in, I need to make sure that that is actually a solution to the question. So I need to check that the cube root of 8 plus 2 is 4. Well, the cube root of 8 is 2, and 2 plus 2 is in fact 4, so that works out. This one we have a word problem, and this is an example of another type of question you're going to be asked in this section. So this is not just solving an equation, but it does say, well, actually it doesn't even say this, but in future questions, you will be asked to rewrite so that you have a different variable solved for instead of the variable that's given. So we have this equation, x equals the square root of y minus 220 divided by 0.010583. And it says, how far is the cable from the roadway when you are 200 feet from the middle of the bridge? So your distance from the middle of the bridge, that's going to be your x, and we need to solve for y. There are equations on your homework where they won't give you a number to plug in for the x, they just want you to get the y by itself. So that's actually what I'm going to go over here first, is how to rewrite this equation so that it's y equals instead of x equals. So since I have a fraction here, the first thing I need to do is get rid of the fraction. So I'm going to multiply both sides by the denominator. So I have 0.010583x is equal to the square root of y minus 220. Well, now to get rid of the square root, I need to square both sides. I need to square the entire quantity that is on the left-hand side, which means I'm squaring the number and I'm squaring the variable. When you square the number, you get 0.000112, and there may be some other decimals on the end there, but that's enough to get a good picture of what's going on. And then I have y minus 220. And then finally, we would add the 220. So I have 0.00, make sure you see my decimal point there, 112 x squared plus 220 is equal to y. So that is the equation that highlights the y instead of the x being highlighted like we had before. So now it says how far is the cable from the roadway when you're 200 feet. So now I'm going to let x equal 200. So I have 0.000. I guess I left off one of my zeros here in this last line. There should be 3 of them. 0.00112 times 200 squared plus 220 is going to equal to y. So you would just have to type that in your calculator, and you're going to get about 224.48, and this is in feet. So that's what your y is equal to. It's approximately equal to 224.48 feet. So the cable with this suspension bridge is about 224 feet above the roadway when you're 200 feet from the middle. I'm actually going to skip this one for right now. This was an SAT question that does deal with radicals. So what you have here, it says if a is equal to this radical and 2a is equal to square root of 2x, what's the value of x? You would have to substitute in the 5 square root of 2 for the a, and then you would go through, square both sides, and solve for your x. So we're going to skip this one for right now. Example 3, extraneous solutions. This is why it's so important for you to check whether a solution actually works in your original question. So this is a one radical equation. To solve for x, I need to isolate the radical, which it is isolated here, and then I'm going to square both sides. You need to be careful though, because I don't have a solitary number on the right-hand side. I have a binomial. So when I square that, I have to square the whole quantity. You cannot distribute the square. You actually have to do x minus 4 times x minus 4. When I square the square root, though, I am going to be left with 3x minus 2. When I square the other side of my equation, I'm going to be left with x squared minus 8x plus 16. If you distribute the square, you will get this question incorrect. So please, please, please make sure that you square your binomial properly. All my radicals are now gone, so I can get everything on one side. So I have x squared minus 11x plus 18. And one of the ways you can also check to make sure you did your math correctly is I believe all of the questions you're assigned, when you have these x squareds in your problem and you have to factor to solve, everything should factor. If you had done this incorrectly, you would have lost the minus 8x, and you would have only had a minus 3x, and there are no factors of positive 18 that add to make a negative 3, so you would get no real solution, when in fact there are solutions to this question. So this is going to factor into x minus 9, x minus 2, and I get 9 and 2 for my answers. Well, let's go back and check this. So if I check the x equals 9, I'm checking that the square root of 3 times 9 minus 2 is equal to 9 minus 4. Well, 3 times 9 minus 2 is 25. 9 minus 4 is 5, and the square root of 25 is in fact 5. So that does work out. But if I check the x equals 2, I have the square root of 3 times 2 minus 2, and I'm going to see if that's equal to 2 minus 4. Well, 3 times 2 minus 2 is 4. 2 minus 4 is negative 2, and the square root of 4 is not equal to negative 2. In fact, your square root cannot equal a negative number unless there was a negative out in front of it. There's no way to get that. That's one of the reasons why we had I exist, for things to happen. So this does not work out, which means x equals 2. That's an extraneous solution. So, we've talked about those extraneous solutions before. They're the solutions that look like they work. and they don't actually work. So just be aware that they exist. Your textbook goes over why the extraneous solution arises. And it's because we're taking something like the one on the left, like this graph here. That is the original problem graph. You have the square root on one side, you have the x minus 4 on the other side. We graph both the lines, and the only place they cross is at the point 9, 5. Of course, 9 being the x value, so 9 would be our actual solution. When you square both of those, then you get what we have on the right. And you can see it changes the problem. It makes it look like there are two solutions instead of just one. However, the 2, 4, that's the one that was extraneous. That's the one that doesn't actually exist. So that's why you need to be careful. We do square to enable us to solve, but sometimes you will get those fake solutions on your way to your final answer. So that's going to conclude our part 1 video. We're going to pick up with part 2, looking at some different types of radical and rational exponents equations to solve. Go back and re-watch this. Feel free to pause and take any notes as needed, and reach out if you have any questions.